Hello there you beautiful people, and welcome to this video on class methods. Now sometimes we want our objects to have certain behaviours and class methods let us do that. For example, we might want to give our coins the ability to rust. That rusting behaviour would be its own method. We might want to let our coins be flipped, which would be its own method as well. Now in this lecture we're going to learn all about class methods and making some to create some behaviours for our coins. In the process, we're going to learn all about class constructors and class destructors. These are special methods that let us set up and destroy our coins when we want to. So by the end of this lecture, you're going to know all about class methods by making a coin that can rust. It can also be cleaned, it can be flipped and be spent, as well as learning about constructors and destructors. So we have a lot to do, so let's get into it. So at the moment we have a very basic class. All it has is a few states, and we want to create some class methods. So to do this, we're going to need a constructor. And in Python, the constructor is defined like this. You type def for define, just like you would with any other function, and you use the init method. And the way that is, you go underscore underscore, init, underscore underscore, and then you put a pair of brackets like that. Okay, so, and actually inside here, you need to put the word self. Now, what this looks like is a function, but we have self as a parameter. And this is our constructor method. Now, what is this self? What's this self going on here? Well, self is what we use to refer to a specific instance of this class when we write the class code. So, for example, if we made coin1 using this class later on, inside the code, self would be replaced by coin1. The name of our instance, okay? If we made a coin called coin7, when the code runs, self would be replaced by coin7. Note that it doesn't have to actually be self. This is just a convention. It could be anything. But I'm just going to be keeping it to self, and I recommend you do too, because that's basically what everyone else uses. Now, inside of our constructor, we're going to move all of these states that we've got inside of there. Use some tabs to knock them in. Okay, so now they are all inside of our constructor. But the thing is, we actually have to, we can't just leave them like value, color, num edges. No. What we've got to do is we've got to type self.value, self.color, self.num edges, self.diameter, self.thickness, and self.heads. So remember, if this was coin1.value is £1. Coin1.color is gold. And it doesn't matter what you call it, it's just that's going to help you set up your states regardless of the object's name. Okay, so by running through and setting up all these states, you're effectively constructing your object states. Okay, you're constructing and making your object work correctly. A constructor could have more than one parameter. For example, let's say it took a parameter called rare. Okay, it could take a parameter called rare, and that's going to be a boolean that's going to be true or false to tell us whether the coin was rare or not. If the coin is rare, it's worth slightly more, and I'm going to say by default that's false. Okay, and in here I'm going to say, okay, self.rare is rare. And if self.rare, or if self.rare is true, it's exactly the same thing, then self.value is £1.25. Otherwise, self.value is just £1. Okay, so what's happening here? If we have a coin, well, let me show you. I'm just going to run all that. That's made our class. Okay, I'm going to take coin1, and that's going to be a pound coin. And its rare is going to be true. Okay, and I'm going to take coin2, make it a pound, and it's rare. I'm just not going to do anything. Okay, is coin1 rare? Yes, it is. Is coin2 rare? No, it's not. What's the value of coin1? £1.25. What's the value of coin2? Just £1. So you can see by taking extra parameters when you define your class, you can change how it's set up. Okay, so Our constructors helped us set up our object states and works in exactly the same way, really, as any other function. Okay, it's just got self at the beginning. And the only difference is that it actually doesn't return anything. You don't type return inside your constructor. Okay, it helps set up your class like this and just make sure you have the self dot. Okay, that's just the way that it is. Now let's say that we want a method that's going to make our coin rust. And when our coin rusts, let's say its color changes from gold to greenish, like this. So it'll change from gold to greenish. Okay, so let's set that back to be gold. So to create a method, we need to be inside the class, and we're going to come down here and type def rust. Now the first parameter to any class method has to be self, or whatever you decided to call it up here. Okay, we called it self, so self has to be down here. Now, okay, so make sure that is the same. If you don't put self in here, the code will fail and Python will tell you something's wrong. Okay, so now what we're going to do is if our thing rusts, then self.color is going to become greenish. Okay, and that's it. Nice and easy, right? So let's see this in action. I'm going to run this again, and I'm going to create coin 1, which is just going to be a normal unrare pound, and coin 2 is going to also be a normal unrare pound. Coin 1's color is gold. Coin 2 color is also gold. Now let's rust coin 1. What we do is we type coin 1 dot rust. Okay, we call the rust method on the coin 1, on the pound object, which is coin 1. Just like, for example, if we had a list, if we had a list 1, 2, 3, 4, and we do dot append, yeah, we say we want to append 5. Then if you look at that, well, that would do something, right? You're calling the list method. Likewise, now we're calling the pound method. We're calling the pound method called rust. So coin 1 dot rust. Now if we look at coin 1's color, we see that it's gone greenish, whereas coin 2's color is still gold. So what if we wanted a method that could clean our coins if they're rusty? Well, let's just go back in here and let's just make another method called define clean. Again, remembering to put self as the first parameter. Okay, and this is just going to send self.color equals gold. Okay, now we can show you what happens here. Let's make a coin 1. Now if I do coin 1.rust, that's going to change coin 1's color to be greenish. But if I do coin 1.clean, oops, I type coin 2. If I type coin 1.clean and I do coin 1.color, that's going to give us gold again. Okay, so the clean method is working as well. All right, now we want to make our coin flip randomly. Okay, so you just, like, you know, when you flip a coin, it's going to give us a random value of heads. So for this, we're going to need to import the random library all the way at the top here. Import random. Okay, and what we're going to do is we're going to make a method down here called flip. Define flip. Again, putting self as the first parameter. Okay, now what we're going to do is we're going to have a list of choices or options, and that can either be true and it can be false. Okay, this is for heads. Maybe I'll call it heads options. Heads can either be true or it can be false. Okay, now to take a random choice of these, we need to do random. So let's say choice equals random dot choice from heads options, if I am correct. So that's going to just take a random choice of that. I need to spell options right. And now what we need to do, self.heads is going to be the choice. Okay, so let's run that. And let's create a coin again. Coin 1 equals a pound. So what's coin 1 heads? It's true. Okay, so it is on heads at the minute. Now if I do a coin 1.flip, and now I look at coin 1.heads, it's now false because now it's flipped to tails. And if I do coin 1.heads flip again, and I look at the heads, it's now heads. Let's try again. Coin 1.flip, coin 1.heads, It's now false, but it won't always do this, right? It won't always go heads, tails, heads, tails, heads, tails. It will randomly flip in between the two. Okay, so that's working great. So finally, we want to allow our coin to be spent. Okay, now spending a coin from the perspective of our program basically destroys the coin object. Okay, so for this, we're going to need to use a destructor method. A destructor is called automatically when our program finishes and is used to destroy an object. And the Python destructor is called underscore underscore del underscore underscore. And you got to put self in there as well. So init up here is our constructor, and del is our destructor. And by the way, I could define the destructor up here. It doesn't have to be at the bottom. Okay, rightio. Now then, let's actually make this work. Okay, all we want this thing to do is to say coin spent. Okay, when the coin has been destroyed. Awesome. Now, how do we actually make this work? Well, let's go in here and let's create coin 1 again. It's going to be a pound coin. Now, all we have to do is use del coin 1, and that's going to say coin spent. And you can see now that coin 1 is no longer defined. The same will work for coin 2 as well, of course. If I set that equal to a pound, I can flip it, right? And then as soon as I delete coin 2, it's going to say coin spent, call the destructor, and coin 2 is no longer defined. We've spent and deleted our coin. Awesome. So we've now got a coin that can rust, it can be cleaned, it can be rare, it can be flipped, and it can be spent. What more could you ever want from a coin? So let's have a quick recap of all the cool stuff we've done in this video. In this video, you learned all about class methods. We started off by looking at the init method, which I'm just going to browse to right now. We started off by looking at the init method, and which we used as a constructor to construct our class's states. And it allowed us to do methods because we needed this self keyword here. So then we made our rust class method, which changed the color to green. We made a clean method, which changed the color to gold. And basically, what I want to get at with this is you saw the way that coin 1 and coin 2 could have different internal states to each other, right? One could be rusty and one could be normal, and it doesn't matter what the other one is doing. Now, this is the object-oriented programming principle of encapsulation, where your states can be encapsulated inside a bubble and hidden from each other. So we saw encapsulation as well. We made another class method that cleans it. We can flip it using the random module. What else did we do? And we also encountered the destructor, right? We encountered this del function here. So the del function, or the underscore underscore del underscore underscore, is our destructor, and the way that you call that is if you have a coin, say it's coin 1, you just type del coin 1, and that is going to delete your object by running the destructor method. So we've totally just modeled a pound coin in code. That's pretty epic, right? It's not bad at all. Well, the only issue is, what if we wanted to create all the other coins? Okay, what if we wanted the 1p, the 2p, the 5p, the 10p, the 50p, and the £2 coins? Well, as you can imagine, that would be a whole lot of typing if we did it the same way as we did here over and over and over again, right? Well, luckily, there's an object-oriented programming principle called class inheritance that's going to do a whole lot of this work for us. So in the next video, we're going to create all of these coins. That's right, we're in about 1 or 2 videos, we're going to create all of these coins and learn about the other object-oriented programming principles of inheritance and polymorphism, which are super cool. So I'll see you in the next video.